This video is about implicit differentiation, and even before diving into that implicit differentiation, let me tell you what is implicit and what is explicit. If you have a function y is equals to f of x, then this is an implicit this is actually an explicit function, because here y is explicitly defined in terms of x. You can have y on one side and everything else on the other side. So if you can write your function or your relation like this, then you can say that y is an explicit function of x, and then you can use any of the previous techniques to find the derivative. You can find dy by dx. On the other hand, if you have a relation of this sort, if you have a relation x squared plus y squared is equals to 1, then here it's not, in fact, it's not possible to write y as a function of x. So this is an implicit relation. So if you feel inclined towards geometry, you can say, you can see that this actually represents a circle on the 2D plane. But if you don't worry about it, this cannot be written as a y is equals to some f of x. But still you can talk about the derivative of y with respect to x, and that's what implicit differentiation is all about. So to find the dy by dx, the derivative of y with respect to x, what you do is you go ahead and straight away find the derivative on both sides with respect to x. So what you do is you find d by dx of the left hand side, which is x squared plus y squared, and you say that it will be equal to d by dx of the right hand side, because if this left hand side is equal to right hand side, then its derivative will be equal to its derivative. So yeah, and if you see clearly enough, on the right hand side the derivative of a constant 1 is just 0. So I can straight away write the right hand side, it's 0. And on the left hand side I have a sum of two quantities. So according to the rules of differentiation, the derivative of the sum is sum of the derivatives. So I can split it into two derivatives, d by dx of x squared plus d by dx of y squared. And the very first term is it is again standard derivative. It's derivative of a power, so it is nothing but derivative of x squared is 2x. So I can write a 2x over here, plus this is derivative of y squared with respect to x. Now y, if we assume it to be a implicit function of x, then I can use the chain rule here to first find the derivative of this with respect to y, and then multiply it with the dy by dx. So if I were to find the derivative of y squared with respect to y, and then I need to multiply by dy by dx. This simplifies to this using the chain rule. This is what you get for this. It's just a simple application of a chain rule. And of course on the right hand side I have a 0 up front. So what we get here is this is just a 2x. Now derivative of y squared with respect to y is again similarly it is a 2y, just like a derivative of x squared with respect to x was 2x. And what we have here is dy by dx, and which was actually our ultimate goal. We ultimately wanted to find dy by dx, so I'll write it as is, dy by dx is equals to 0. And then if I were to manipulate this a little bit, if first of all I can divide both sides by 2 to get rid of these two, so I'll be left with just x plus y dy by dx is equals to 0. 0 divided by 2 is just 0. And then I can get rid of this x by shifting it over here, or subtracting x from both sides. So I can get rid of this x by saying this is a negative x. And if I were to solve for dy by dx, I would need to get rid of y. So y is being multiplied here. So if I can divide both sides by y, I can get rid of this as well. So if I divide both sides by y, this becomes this. So if I were to write it very neatly, it would be dy by dx is equals to what I'm left with is negative x over y. And then yeah, this is it. You have found the derivative of y with respect to x, and often if you are doing implicit differentiation, you'll end up with some terms of x and some terms of y. The reason you may not end up completely in terms of x is because y cannot be expressed in terms of x, because here, remember what we started with. We started with an implicit relation. Here y was not a function of x. We could not express y as a function of x. So there is a possibility that you'll be left with y somewhere in your answer. But yeah, this is how you find implicit derivative, where if you have a relation where it is not evident, the y cannot be expressed as a function of x, you go ahead and take the derivative on both sides and try to apply the chain rule while finding the derivative of terms involving y, and the relation that you get finally is this. For this example, the derivative dy by dx is minus x by y.